Great, thanks. So I'm just curious, how many of folks that are in the room have heard about device health attestation feature? Okay, so it's better than last year. Thank you. So today's session, basically, I will cover two things. One, I briefly go over the security challenges that enterprises are facing, and then how you could address or how you could use device health attestation to address some of those risks. Now, so I was just looking at some of the surveys. I mean, if we look at the investments that we are making on security, we are making a lot of investments. Like in one of the Gartner reports, they said typically organizations spend between 4 to 10% of their IT budget on security. And what was interesting is companies that they spend the least amount, some of them are the most secure company and some of them are the least secure companies. That means that we are spending a lot of money on security that doesn't go to the right place. And that was kind of news to me. Now, there's a type of attacks that we're hearing more and more about, and they are called the advanced threats or advanced attacks, jailbroken. Basically, these are type of attacks that they infect the device at runtime, or even before the device comes to you. Somebody intercepts it, inserts something on the device. Now, because these exploits, all exploiting firmware vulnerability, things that are below the operating system stack, they are very powerful because they can just simply hide themselves. Different ways they come in. They either come in through the boot or firmware vulnerability or configurations that are relaxed. Then when the device boots up, they can hide themselves. Some of them you cannot even detect them remotely or even locally. Now, some of these things I've seen that they persist across multiple reboots. Even if you clean up, re-image the device, they come back because they're in the firmware stack. And they are used in so many different ways. Some of them, they function as backdoor. Some of them, they function as rentals, like, believe it or not, like people, they rent computers to do things on the internet, and there's a market for it. So when your computer gets exploited, it gets abused in so many different ways. This type of exploit, everybody has it. Like we had one last year. This was in our bootloader. And because, again, this was before operating system takes over, operating system cannot detect it. Now, we created a patch, and this issue is fixed. But what bad guys could do, they can pretty much downgrade that component. And if they are able to do that successfully, they can just remain hidden for a very long time. And with this vulnerability, you can do things like disable secure boot or enable test signing and do all of these things without operating system knowing it. Now, when this type of vulnerability comes up, one of the way of detecting it, and I can say maybe the only way that we have in Microsoft, I mean, some other companies, they offer solutions, but it is with a feature called device health attestation. And that's the feature I'm going to talk to you about. Now, when these things comes in, we have this messaging that we very much say that contact your device management solutions, because when something bad happens, we don't want, bad guys to abuse it. But basically what we do is, I will show you how device health attestation works. You could see the result of it in your device management solution, and your device management provider has information that, can tell you how you can detect this. So it's a really good idea that if you're running a company, have a very good relationship with your device management provider. Make sure they are up to date and you get up-to-date information from them. And if you see this text, that means, okay, contact your device management solutions. If they don't have a solutions yet, that is something that you can report to us and we can help them to bring it up. Now, before I get more deep dive on technical data, do you have any questions? Anything? Okay, moving on. Now, one of the most important concepts in security that everybody forgets is you're as good as your weakest link. And that's why all these security investments that we are making, we don't see the return of it as much as we should. Because let's say you're trying to create a perimeter around your data, and you have let's say, PC devices that they come and access the data. They're all protected. But you have one mobile device that is not secure enough, or you cannot really check security before you allow access. And that is good enough for the bad guy to come in. So it is very important, like when we're investing on security, we look at everything at the big picture and make sure that we create protection that is in the same strength for all the data or all the processes that access the data. Now, if you want to look at weakest link, I mean, we have to go back to the factory. You have a factory that creates TPM. This is what we use in health attestation. It's trusted platform module. Then it goes to OEM, and these are the companies that they put devices together, like Surface is an OEM or Dell. Now the device gets shipped to you. So here, a lot could happen. Device could get intercepted. And this is something like if you search for supply chain attack, you see there's a good article on it on WikiLeaks. Then the device comes. Here I have, as an example, I'm showing a data center scenario. Comes to the data center. Provisioning is another thing that vulnerabilities could get in. Now, daily operation, that's another entry point for different vulnerabilities. And then you have backup processes, business continuity, and also decommissions. And I've seen security issues coming through almost anywhere that it could come in. In terms of breaches, you are dealing with folks that are malicious or external. You're dealing with malicious administrators or even operators that are malicious. They try to do bad things or logic bombs. And then you dealing with errors. If you look at the security issues and try to get a percentage of how much of it is caused by error, how much of it is caused by a malicious activity, or I can say better, how much of it is initiated by error, through an error, or how much of it is initiated through a malicious actor, you see most of the problems are coming from here. Basically, somebody forgets to do something, and then that opens the door for vulnerability. And when we look at, we are dealing with firmware bugs, boot component bugs, kernel, application level vulnerabilities, and also the policies that they manage the device. And the tools that we have that we can deal with is attestation. Now, I mentioned that, okay, we are spending a lot on security, but we are not seeing return in our investments. If you want to guess, what do you think is the single thing that we could fix that would help us to get the most out of our secure environment? Data quality. Basically, right now, what is happening is that you have very advanced technologies that they are detecting, very advanced technology that they can enforce all the different type of corrective actions, but the data that they operate on is low quality. Because what happens is that when a device gets jailbroken, it just simply lies to you. And you have no way of finding it out. So if we raise the data quality that our security processes are operating on, then you will see a huge bump on risk that you find that you didn't know. And also in time, you will have a much more secure environment. Now, in terms of what are the things we could use? Now, before Windows 10, basically all the tool sets that we were creating, they were terminated from a security perspective at the operating system stack. And as long as you have a logic that terminates at the code level, that is software level, that means that if somebody remotely can access that or find the vulnerability, they can own it. Now, what we are doing with device health attestation, we are lowering the root of trust, getting it as close as possible to hardware. For example, Xbox is a product that we produce. We own the hardware, so it is very easy to validate that, okay, is the hardware the authentic hardware or the firmware authentic firmware. But in words that you have multiple devices, we needed to have a hook, something that we can rely on that cannot get influenced by what is happening on the operating system or the software stack. And that is TPM, Trusted Module Platform. TPM comes in 3 different forms. Discrete TPM is actually a physical chip. Then we have the concept of firmware TPM. It is the same logic in firmware, but in a hardware protected storage. So from a security assurance perspective, they provide the same security bar. Discrete TPM was the first TPM that came out, and that was TPM 1.2. The new version of TPM, TPM 2.0, supports both scenarios. So if you have a phone, Windows phone, it will have a firmware TPM. Or actually, I'm seeing a lot of firmware TPM even on desktop devices. And then there is a third category. It's called virtual TPM. This is what we have in virtual host that virtual environments that they come up on host. They are TPM, basically the boot gets measured, but at the end of the day, the security of what TPM does is terminated as a software stack. So from a device health attestation validation perspective, health attestation works with virtual TPMs, but you don't get much security assurance out of it. We focus on discrete TPM and firmware TPM. Now, TPM, basically, it is a very simple security logic. We try to keep it simple so it doesn't add too much expense to the device. And basically, it does a series of very basic operations, and it is slow. For example, you can use TPM to generate a random number. You can do some hashing operation and very limited crypto operations. Now, TPM has a series of keys and certificates. There are two certificates that we use in health attestation. One of them called EK certificate. And this is basically a certificate that is provisioned during manufacturing. And the other one called AIK certificate. And that is a certificate that Microsoft issues if a device meets a certain condition. Now, let's look at the manufacturing flow. Here's the factory. Basically, every TPM has a unique identity. When it is created, there are a series of secrets that they get fused, and they are used to create a series of key pairs. Now, EK key pair in the factory gets signed by the manufacturer. So this is how, by checking at who signed the EK certificate, we could see who manufactured it, and we could see is that a trusted manufacturer. Now, the device comes up, user turns it on, user turns it on. And what happens is that if the device has access to the internet, Microsoft, through the UBI, challenges the device. And if the challenge passes correctly, it issues another certificate called AIK certificate. So one difference between EK certificate and AIK certificate is that EK key or its certificate stays the same for the lifetime of a device. But AIK changes every time you provision a device, every time you re-image a device. And AIK is more privacy friendly because it is not as sticky as EK. Device health attestation, I get more into the detail, but supports all these different scenarios. Now, I mentioned that when you talk to a device, you're talking to the operating system. And if a vulnerability could own the kernel or operating system, it will simply lie to you. And this is what is happening in real world. When people are managing the devices, they're talking to the software. And when the device tells them that, okay, I'm healthy, they give access. If you want to kind of have a parallel example, it would be almost like the management point is like a police officer that stops the car, and you want to catch bad drivers. And instead of, making sure that you're talking to the right guy or you have the right information, you just ask the guy, are you drunk? And of course, the driver is going to say, no, I'm not drunk. And then they go in. But you see, that is not how police officers operate. First thing they do, they ask for driver license and registration. And basically, that is a root of trust. It is almost like attestation. That first they're checking to see, okay, am I talking to the right guy? Is that guy trustable? So basically, if you don't pass a certain basic validations, you don't even go to the next level. If you don't have a driving license, the communication stops. Now, device health attestation allows you to do a similar thing. Basically, you can look at the boot, you can get information, and aside from getting a data point that tells you, okay, secure boot was enabled or not enabled, you also get more data points. You know what TPM was used to attest this data, or even if a TPM was used to attest this data, you can kind of limit the number of TPMs you trust. So you have general control over how you could do. And then instead of just assuming things, you can validate things, authenticate things, measure them, and make sure they are in the state that you want. Device health attestation is a feature that was built on capabilities that we created in Windows 8, like Secure Boot, Measure Boot, Early Launch Anti-Malware, and TPM attestation. And basically what we are doing, we are enabling administrator to remotely talk to the hardware and get information in a TPM-protected, tamper-resistant, and tamper-evident communication channel. Now, what that means is that, let's say if a device is jailbroken, they can stop this report from coming to you, which is a signal because you expect to hear back and you're not hearing back. but they cannot touch the integrity of the report that comes to you or falsify anything. So that is a powerful tool that we could kind of catch many scenarios that we couldn't catch otherwise. In a device health attestation flow, basically you have a device. It is any Windows 10 device that has a TPM 2 or 1.2. There's a service called Health Attestation Service. This is the service that provides the information. And it comes in both flavors, cloud and on-prem. If you have Server 2016, you can run your own health attestation, or you can use the cloud version of it, which is a free service by Microsoft. And device management solution, there's all different type of device management solutions. We have first party like Intune SSCM, and there are third party like AirWatch, Mobile Iron. And device health attestation is created based on OMA standard. So it is open to any device management solution to integrate with. Or even if you want to create a custom solutions, the information is there. Just you could start integrating with it using OMA standard calls. Device management solutions also, they come in both on-prem and cloud version. And we have enterprise assets that we are protecting either on the cloud or on-prem. The way it works is that there's a communication between the device and the service, and then there's a communication between MDM and the device, and the MDM and the service. This is how the flow works. Here we have a snapshot of a device. Here is a service. Here the device management solution. The logic for health attestation is in every Windows SKU, but it is not enabled. It's a mute logic. So it doesn't matter if you're enterprise, home, or professional. This capability is in your device. Now, this capability becomes enlightened when a device enrolls. When a device management is DHA enabled, means that has this capability to talk to TPM, get this report. They have a series of settings that they can set on the device. One of them is that you tell the device every time you boot or reboot, send a series of information to this service. Now, the service, basically the information that are sent to the service are information that are collected by TPM. These are TCG logs, their signatures, and also the certificate of the TPM. Service looks at that and creates a very small encrypted blob. Now, this encrypted blob is encrypted by a key that is here. So the device itself cannot open it or read it or do anything with it. Can't even replace it with another one. Now, the device management solutions, anytime, at any interval that they check health, what they do is that they send a nonce. Now, the device, what it does, it creates a package of 3 different data points. One data point is the boot state. Second data point is the current state that TPM gets a snapshot, and also the cert that was used to do this attestation. And another thing that is in the sent to the device is the nonce that the server sent you. And we can go to the details of different attack scenarios, but basically we have protection from all different type of man-in-the-middle attacks. And if you find any vulnerability in this flow, let me know. It has been reviewed. Now, this device management solution gets this information. They cannot read it because it's encrypted. What they do is that they send it to the service and they get a report back. Now, in the report, what we are doing, basically, we are extracting what is important from TCG logs. TCG logs is a log that TPM, when a device boots up, the boot sequence gets captured in the TCG logs, and TPM also creates measurement that you can kind of validate to make sure that, okay, that log is not tampered with. Now, in the first version of the report, we started with minimal amount of information. Because, I mean, security, too much information is as bad as not enough information. And we didn't want to confuse the IT admins. Basically, we are talking about the BitLocker status, secure boot, code integrity, ELAM driver loaded. And these are all different things that either they are an entry point or they could become an entry point for vulnerability. Or you could use them to detect specific scenarios. For example, PCR0. PCR0 is the signature of the first firmware that is loaded to the device. Now, if this is how you can take care of lots of supply chain attack scenarios. Basically, when you buy devices in batches, they typically have the same PCR0. Even like when you talk to Surface team, this attribute changes maybe 8 times a year in the factory. But basically, if you have a relationship with your manufacturer, you know this value, When the device comes up, you can check to see if it is the same. And if it is the same, that means the device is not tampered with. Reset count, restart count. Reset count is a counter on the device that every time the device goes to hibernation, this counter goes one up. Restart count, every time device boots or reboots, it goes up. Now, can you guess what is the value of these two counters from security perspective? If you look at a device, just capture the reset and restart count in time, you will start seeing a behavior that you can create a baseline. Like devices, typically, especially critical devices, they don't get rebooted, just on their own. So one simple anomaly detection rule that you can find is that, okay, if you see a deviation to how a device is resetting, how these counters are going up, that could be an indicator that, okay, something needs to be looked at. Another good example is CI policy. This is the code integrity policy. Basically, it tells that when we do the integrity validations, in what cases we need to terminate or trigger different type of actions. Now, if you're familiar with device guard feature, is a Windows 10 feature, allows you to create a CI policy. You create a policy, you put it on the device. Now, what bad guys can do is that they can just replace that policy and put their own policy. And you would have no way of detecting that your policy is really running on the device unless if you check it, use device health attestation. So in this scenario, basically, when the IT admin creates a policy, they can hash it. And different MDMs that I work with, they have exposed this capability in different ways, but most of them, basically, what they do is that they allow you to blacklist or whitelist based on a certain attributes. So we released the first version of this feature between those 10. And now what we are doing, we are adding more and more to the report. Let me show you a snapshot of a current version of DHA report, and this is what is coming next. The report that goes to the device management solution that you guys see through their UI, this is how it looks like. Basically, it is a XML with different data points. And you see we have added new attributes. Basically, AIK present is not new. Attestation method, this is a new attribute. So we are telling that what did we use to attest the device? Was it EK, AIK, or we didn't use anything? And this is something that you could use to see how much you can trust that report. Maybe instead of me going through all these attributes, is there any specific ones that you guys are interested to know or you have heard about? And by the way, these are all documented. I will send you a link. But basically, these are information that are extracted through the boot logs. They have different type of security values. Now let me go back to the deck. About implementation options, mentioned before, it comes in different ways. Device health attestation cloud, basically it is a cloud that does this attestation that we host in Microsoft, and it is a free cloud. We run it in 4 different data centers, and we intend to keep it free because we need to make sure that everybody is as secure as they can get. The on-prem version of this service is released in Server 2016. Again, this doesn't have any additional licensing fee. So if you have Server 2016, you could get it up and running and use it. Create your own on-prem. And also you can run Server 2016 on Azure if you'd like to have more control on your data. In terms of capabilities that I've seen built on top of this is basically data collection. Some of the device management solutions just allow you to collect this data so you can process it later. Compliance reporting, some device management solutions, they have built more capabilities and they have different type of compliance reports that they show. Live monitoring, basically the frequency of this check in some of the MDMs that they provide this solution is configurable, so you can just continuously keep an eye on the device to see what is going on. Zero-day incident response. Zero-day is a very interesting topic because you don't know what happened, but you need to catch it. And how would you do that? The answer is relatively simple. I mean, if like all the security problems that we have, if you look at banking systems or physical security, they have solved it. And basically, what you do, okay, most of you guys or some of you guys probably have a home security system. How is the home security system built? At entry points, you have sensors. And then when the system is in a certain mode, if there is a change of a state, then you know something happened. You don't know if that was bad or good, but that is something that requires your attention. And that is when the alarm beeps and other type of corrective action starts triggering. This is the model that the real world uses. Now, if you look at computers, I mean PCs, the way they typically get managed is with antivirus. Antivirus, basically what they do is that they look for known issues, and that is after the fact. And that is not as effective. Like if you want to have the compare, like if you're for your home, you want to build a security system based on antivirus methodology. Basically what you have to do, hire a guy with a gun or something, sits in the living room, and anybody that comes in, checks it out, and if it is bad, starts kicking them out. I mean, you could just, it's obvious, it is an expensive process, it doesn't work. Instead of that, if you keep an eye on the entry point, you can detect things that happen. For example, if you see your accounting system, all of a sudden the test signing is enabled, that means either you have a bad administrator that has exposed the vulnerable device outside, or you have somebody that has found a way to get in and is starting a multi-phase attacks. So it is a very powerful tool that you can get early indication of attacks and start mitigating. If you look at kind of analyze cost of a compromise, things that happens, the initial breaking usually doesn't cause too much damages. The damages is that when the bad guy stays in your system for years and years and you have no way of finding out. So even if you cannot catch something right away, if you know it soon enough, you can deal with the impact of it. And if something doesn't have an impact, it is irrelevant. Online enforcement. Basically, some of the MDMs, what they do is that they have integrated this with different online enforcement mechanisms that they have. For example, conditional access is one of them. You can integrate that with device self-attestation. And basically, the way the flow would work is that when a user wants to check a document, you kind of validate their device self before allowing them access. If you have time, there's a flow that I can show you how it works. And then out-of-band enforcement, and this is also very important. You could trigger all different type of alerts depending on the MDM you're using, or different kind of corrective actions based on what situation you're trying to fix. Like, for example, you can email people, you can send the device to a honeypot so you can look further inside what is happening. Or I've been talking to some schools, they said if somebody jailbreaks their device, they don't want to deny access, they just want to send the guy to the principal office. So it is not only online enforcement that is important, all different type of corrective actions that happens out of band. And this is typically what helps us a lot to mitigate risk, reduce cost of an attack that you could trigger. Mentioned, and this is something actually I should have updated today, more and more MDMs are integrating standards. I mean, everything is published. The integration is relatively simple. We made this feature very easy to use. So if you are working with an MDM that supports it, you just turn it on and you see it work. And MDMs, they have capabilities that they let you, if you want to use on-prem, you can have your on-prem server or not. If aside from who is here, IBM, Mass 360, BlackBerry, and a couple of other MDMs are working on it actively, and their solutions will be ready in RS. In summer around with RS2, RS3. If you are using an MDM, or if you are an MDM that need to integrate, I mean, I have my email at the end. I can jumpstart your integration process around some scripts, and I can show you what needs to be done. And we'll help you to use the feature. What are the dependencies? Like if somebody wants to use the feature, basically you need to run Windows 10. Any of these SKUs, they support it. You need to have a TPM. TPM 2.0 was supported from the TH1 release, day one, and TPM 1.2 was added in RS1. and these are the OSs that are out. You need to have access to the cloud service, or you need to run your own on-prem service. And the last thing you need is a DHA-enabled MDM, Intune, SSCM, AirWatch, Mobile Iron, SOTI, Citrix, IBM. If you are, some of the difficulties I've seen customer having is that in MDMs, they have a big team and not everybody knows about all the features. So if you're working with one of the MDMs, you have hard time finding the right team to talk to about how you want to enable this feature or what are the capabilities you want. I can kind of connect you to their dev teams. We work with them on continuous basis. All the MDMs, they're looking to hear from customers. Basically, they did a very basic integration with device self-attestation. Now, the feature sets, what makes this feature useful is what is customer driven. So if there is a specific capability you want, you can talk to your MDM and they can just add it. And it's just a matter of timing. There are multiple documentations in the internet. There are specifically 2 documentations that I want to point you to that we keep up to date. So there's this guy. This one has a very good summary of how this system works, and it is targeting folks that they want to run the on-prem scenario. So it tells you how you can get device self-attestation service up and running on server 2016. It is a complex process, and partially it is by design, because as you set up this service, you need to make a series of security decisions, and we didn't want that to just be automated or come up like willy-nilly. For example, you need to decide what is the chain of trust I want. So again, folks that they are running a DHA service on their premises, they need to have a security team that is knowledgeable, can keep this, or simply you can use the cloud version. The second document was targeting device management solution providers. It starts with more clarification how different components works and deep dives to how the configuration service provider is architected and how you can talk, integration steps, because this is not a typical CSP. We made it like a 1, 2, 3, 4, 5. That's 8 steps that you go through. And there are sample code snippets for every step. We try to make it really easy for everyone to integrate with. And at the end of the document, you have the report attributes, what we are reporting. And this is something that we keep on adding more as we identify more data points or we get more requests. So if there is a data point you would like to see in the report, you can let me know. And if something has a security value, we will add it. But at the same time, we are very conscious of we don't want this report to get too big, because then it becomes like, let's say, mobile devices, they pay for the data. So we want to keep this as small as possible. But if something has a value from security perspective, we will add it in. These are what are in the RS2 report. This is the updated version. And you could see some of the attributes. They have asterisks that it is either, that the specific attribute is reported at a certain condition, or maybe there's a bug kind of explained here. For example, which one was it? TPM2. Yeah, the first one. Yeah, that's what I'm thinking. So the reset count and restart count, you can't use it if your device has TPM 1.2. This is only reported in TPM2. And when you go to each one of these attributes, there's description of how they work. You have some recommendation. Microsoft recommendation basically says that, okay, this is what we think is good, but security of a device is tightly coupled to its runtime. So there's no black and white that you say, okay, this device is secure. For example, if you are running a development company, some of your devices are going to have test signing enabled, and that is not a security problem. So understanding, understanding your runtime and how you could kind of monitor that runtime, the more you know, the more effectively you could use this feature. Like these are, let's just go quickly. Secure boot enabled tells you if secure boot was enabled during the boot. Now, actually, this is an interesting one because you can also ask the operating system if secure boot was enabled. Now, if you ask the operating system through a different CSP, An operating system tells you BitLocker is enabled, and then you check the boot sequence. And boot sequence says, no, it wasn't. That is an obvious sign that the device is lying to you. These debugging capabilities are things that they can get turned on through the boot sequence. And these are lots of jailbreak issues. They come through this type of debug capabilities. So they need to first enable that in your device, then they can get in. And these are typical things that you want it to be in a, for example, OS kernel debug. There is no reason for it to be enabled on a device, unless if you're a developer. So in most of the production environment, you shouldn't see any of this debug capability enabled. But you will be surprised. Like first time that you run health attestation on your environment, you'll be surprised what you see. And these are just issues have a way of getting into your systems. Code integrity enabled. This validates the code. These are all capabilities that are enabled by defi, but a bad admin or somehow they could turn it on. Some of this capability, you can remotely address the issue, and some of the MDMs, they are providing this capability. For example, if test signing is disabled, the corrective action could be quickly, okay, enable it through shooting a PowerShell script to the device, send an email to the IT admin, or other type, depending on what kind of organization you're running, you can have different type of corrective action. Safe mode. Like this was one of the attributes we were kind of struggling, should be added to the report or not. Safe mode, basically what it means is whenever your device crashes, it goes to the safe mode. Now, what is the value of that from security perspective? The value is that lots of these bugs, they are low quality code that they take your device to unstable condition that causes safe mode. So all of a sudden, if you see a device going to safe mode a lot and you didn't expect that, that would be a sign that something happening here that may be malicious. Provisioning, that's another thing. So yeah, so these two documents, we keep them up to date for every release. They include right now RS2 information. Shortly we will update them to RS3. We are expanding the scope of health attestation. Right now, you could only use this through modern MDM managed scenarios. We are adding more capability like enabling it through group policy and also opening it to more use case scenarios like local apps. Now, let me go to the next slide. Yeah, that's my email address. If you have any specific question, feel free to contact me. Now, what I want to show you is the conditional ask access flow. And you could see how device health attestation works in a production environment. So one of the things about device health attestation service, this is a stateless service. So basically, if you have an environment, you can easily just bring it in. It doesn't need to be part of AD or any other organizational grouping. In this example, we have a Intune managed or CM managed device. You have different components on the device. This is a Office 365 resource, like a Word document or Excel that is on a cloud. Device health attestation service. This is your device management solutions. And there's a component called AAD and cloud scenario. That is how we kind of manage devices. So what happens is that when a device comes up, it starts the attestation flow. Now, the device management solution, in parallel, it starts asking a series of questions from the device and also sends this information and gets a snapshot from health attestation service. Now, after you ask all the questions, for example, device's patches status, let's say password complexity, things that you typically get, you look at those data in the context of how the boot came up, and then you could make a compliant or not compliant call. Basically, what your health attestation does, it gives you more data point to evaluate the device and also gives you more assurance about what you are evaluating. Now, this compliance or not compliance state is a binary state, is sent to device to AAD. Now, when a user wants to open an Office document, first thing they need to get a token, and that token is issued only if a device is in a compliant state. A variation of that, this is a cloud VPN scenario. It's the same flow, but you just have different components acting. Device. Here, aside from AAD, we also have mini CA. That is the entity that actually issues the short-lived certificate. In this flow, again, the device comes up, health attestation flow starts. The device management solution is asking other questions based on all the information it receives and the policies that IT admin had created, makes a call. Is this a compliant or non-compliant device? Sends that information to AAD. Now, when a VPN client wants to get access, basically they need to get a certificate. And again, that certificate is issued if a device is in a compliant state. Now, the certificate for VPN is a time-bound certificate. So you can kind of manage the frequency of this check by expiring that certificate and restart this flow. Now, I wanted to, at least we have 15 minutes in case there are any questions. And if you guys don't have any questions, I'll be around and we'll be happy to talk about the specific scenarios or things that is specific to your runtime. Please.
How is an endpoint supposed to respond if the DHA service is not cannot be contacted for even once or a longer period of time?
Yeah. So one of the things that you can see on health attestation report is the issue date. So you can build freshness compliant policies that if a report is, let's say, more than a day old, or I don't get it at a specific time, then you could, again, trigger different type of corrective actions. About health attestation service, the way we built it, it is cloud. So it is as good as it gets. In the on-prem scenario, yeah, you're right. It needs to be a high available environment. Mm-hmm. Now, when people want to use this feature, like one of the first things I recommend is that don't use it for the enforcement first day. First, you need to understand the environment. The best way to use this feature is at the beginning, you just collect the data for a month or two. You start looking at what is happening. You start cleaning up the environment. And again, we turn it on in different environments and we're surprised, like IT admin, oh yeah, secure boot is on in all my devices. And in the report, you see 50% of devices, they're not. So first, I would say just use the reporting capability. Then you could kind of look at your uptime, look at the criticality of the resource that is getting accessed. User experience is very important in security. And it is because if something is so hard to use, nobody would use it. Now, in terms of your scenario, we have the risk of the service going down. What I would make a decision is based on the data.
I was more looking into the scenario where it's explicitly been made not so you can't contact it. Yeah. So denial of service and such.
Yes. So we have one classification. It is the data that you have. Let's say if you have a top secret data, then you want to be on the conservative side. That you would say that, okay, unless this service is back up, don't give access to anyone. Now, if the user is accessing LBI data based on the risk, you could kind of see, okay, I don't really care. I can just give it access even if the service is down. MBI data, you can kind of create a balance between user experience and security based on what you need. But we have to build an environment that access to the service is at least you need to have like 3 or 4 9 high available service for attestation if you want to use it for enforcement. So I would say that first, you shouldn't let the service go down. Mm-hmm. Second is that you kind of, in the context of the runtime and the data is coming, you kind of create rules. Another advice that I give to organizations is that always start with relaxed rules and little by little add to it. So in this way, you could kind of see how the environment works or flight it. And you see if what is happening is acceptable or not. You could think about security of an enterprise almost like you have an airplane and you have to fix the stuff without coming down or crashing it. Now, understanding how the more you understand how the environments work and how the risks are, then you can start managing them. I'm not saying to prevent the risk from coming, but manage it in a way that it doesn't impact you in a bad way. So I'm not sure if I answered your question.
Yeah, exactly.
Yeah, thank you.
One sec.
Sorry. Yeah. Yes.
Thank you. So do you have a trusted execution environment, something like that sort, in addition to the hardware?
Yeah, we have VSM, we have host guardian service. There's a series of different capabilities that I don't know if they had a chance to present here, that they complement what health attestation does. For example, VSM is a trusted execution environment. And with health attestation, you can validate if the VSM is in a trusted mode. And then after that, you can refer to VSM. Yeah, and that would be your trusted execution environment or device guard, or there are multiple features that they create these environments in different ways. Even like modern apps, that's like a sandbox environment. Did you have a specific scenario in mind when you asked this question about the trusted execution environment?
Yeah, well, we do. I think in addition to hardware, we see the software is extremely important, protecting data and programs.
Yeah, I mean, software is extremely important. There is no doubt about that. But we have protection mechanism that if they are working, they will take care of the software issues. Like, for example, if you are worried about, I mean, buggy software is a different problem. But if you are worried about malicious softwares are not signed. So somebody needs to disable signing or enable test signing on your device. Then, they become active. So if with this feature, you can assure that all the execution environments are working as they should. And when that happens, you shouldn't have to be dealing with software vulnerabilities. Like, for example, there's nothing to justify that you have a modern app and through that modern app, your device gets owned. Maybe they can just do something in the context of those apps. But this is part of creating that biggest story of trusted execution environment going all the way down from hardware.
My other question is, do you also have like use cases for IoT?
Yes, IoT. So we started attestation for Windows and phone, and we are expanding to other areas. IoT attestation, that is actually a prerequisite. So IoT devices, it is a different type of runtime with different type of problems. But yeah, we're working on creating attestation for almost any form factor. Thank you. Any other questions? Please.
This device health attestation is mostly done at boot. But if you take in a WannaCry scenario, then what do you do in that case?
Yeah. We do health attestation at boot. You could repeat it later if you want, but you will get the same result because these entry points that they protect the device, you need to reboot the device. So in a way that you don't need to do it too often, because every time the device boots, you definitely want to do this. But with this, you cannot fix every security problem. Like WannaCry is one of the edge case scenarios that I was looking at. And we are starting to add more capabilities to basically, okay, I'll give you a preview. Have you guys heard about AMT Intel issues? Yeah, that's another big vulnerability that is out there that basically has been around for a very long time. And when a device is vulnerable, then they could kind of own the device replace everything without anything getting detected. That's a vulnerability that we cannot detect directly during the boot, but the way we are detecting it, and that is in the next report, that is in RS3, is that we look at AMT state after the device boots up. Intel AMT scenario, if you are not provisioned, you don't have a problem. If your firmware is up to date, you don't have a problem. You have the problem if there is no update for the firmware and you are provisioned. It is in provision mode. So the way we are attacking that problem space is that we generate a health report that has the boot information and the operating system information that is collected in the context of the boot. So Yeah.
But if you're saying you have to be up to date, then that pretty much eliminates any 0 day.
Yeah, and the problem is that there are not that many updates available. If you have dealt with firmware problems, you see, you don't get the same quick update response because, I mean, the update, especially that case, has to be created by OEMs. If you look at your OEM, most probably doesn't have the fix now. So you will need to live with that issue for some time. And the way that we are enabling everybody to manage that risk is just getting visibility to what is happening. Yeah, I wish we could, solve all the problems, but this is basically as good as it gets from detection perspective. Any other questions? Okay, so thanks everyone for joining us. We really need your feedback. If there is any issues or specific scenarios that you are interested in, let us know. And